What's up, everybody? Today I am having a special privilege to host legendary Mats Torgersen. So he is a lead designer of C# programming language and principal architect at Microsoft. When you think about C# features, when you think about C# specifications, you should definitely think about Mats Torgersen. If you think you need to have some features on C#, you should definitely check it with Mats. So Mats, thank you very much for accepting our invitation. I'm really happy to have you today, and I'm really excited to have you today.
Awesome. Well, thanks so much for the introduction, and I'm looking very much forward to today's conversation as well. Yeah, it's going to be fun.
Thank you very much. So before starting, I just want to mention that before joining Microsoft in 2005, Mats was an associate professor at Aarhus University in Denmark, where I worked on object-oriented programming language, and he was also one of the influencers about Java generics. Yeah, we'll talk about this feature also. Cool. So I'm really excited to have you today, Matt, and I want to start from our foundational and let's say a bit philosophical questions. So, my first question is, what are the biggest influences and inspirations when you are designing features for C Sharp?
So, of course, there are several. I think that when you're designing a language like C# that has a lot of users, then there's always like a lot of incoming suggestions and complaints as well, and so in a sense, the current users are often the biggest inspiration in the sense of we need to do something about this area, or here's an opportunity we hadn't thought about to go take the language in that direction and improve some scenarios there. So that's sort of like where that's the our users are kind of our proving ground and inspiration at the same time, right?
That's
That said, of course, there are many programming languages out there, and I've been involved with several of them and followed many more over the years. And we certainly participate in the big kind of meta community, if you will, of programming languages.
that's great.
Sometimes we steal a feature, so to speak, or borrow or get inspired, whatever word you want to use. And sometimes we're the ones who go who are like in front with something, and other languages pick that up, and that's also very fruitful interaction. The sort of the state of the art moves along in sort of like this unspoken collaboration between many different programming languages. So those are kind of my two. That I have a foot in each kind of camp, if you will, as C# itself and its users, and then there's sort of the programming language community.
Oh, that's great. So community always matters. That's a great answer. So regarding to C# features, what is the one feature of C# that you are particularly proud of developing?
Async await.
Oh,
I'm proud of many features, and whenever we finish a feature, that is the one I'm most proud of. But if you look over time, async was singularly successful, both in terms of addressing the problems that C# and .NET had with asynchrony and how hard asynchronous programming was prior to that language feature.
definitely.
So within the community, and also kind of hooking back to those two camps we talked about just before, also in the programming language community, it like you can't throw a rock without hitting a language that has async await now, and that started with C#, and I was a driver of that. So I'm immensely proud of that impact to programming. Yeah,
That's really
so that's
cool.
easy. That's an easy one.
So, if I'm not mistaken, you also participated in adding the pattern matching, nullable reference types to C#, yeah? How about this feature?
Well, I think for both of those two features, I am really proud of how we did them. It's not it. it's different from async in that we weren't maybe breaking new ground as much with those two features. Like especially pattern matching was very well established in the functional programming paradigm, and it's sort of like the main way that you do things across different types of data is pattern matching in functional programming. So it's very well established, and there were some object-oriented programming languages starting to dip their toes in it as well. But I'm really happy about the way that we ended up being able to do it in C#. I think we managed to make it fit super well with the sort of dominant object-oriented paradigm, if you will. Like it fit more seamlessly in the language than you might have feared, even though it was sort of like alone from the functional paradigm. So I'm really happy about how that turned out. And I think also, I think a surprising number of C# developers haven't really dared go into pattern matching much yet, and you can certainly overdo it, but I encourage you to take a second look, because code can really get so much more elegant when you use pattern matching. Use it sparingly, use it when it makes sense. Don't like have 3 nesting levels deep, maybe, even though it technically allows it. But if you use pattern matching, right, then your code can become so readable and so maintainable, because you just have this, like, use switch expressions in pattern matching. You can see the conditional logic so clearly from the code in a way that traditional if-else and
exactly.
has a much harder time doing. So and nullable reference types, it was both novel and not novel, in the sense that there certainly has been a lot of nullable analysis around. And there are some languages that are very, mostly again functional programming languages probably, that have like a very strict notion of nullability, where it's like deeply baked into the type system. And that's kind of, that's something, it is very limiting in some ways. It fits better in a language where that leans into immutability a lot, and a few other things, but it's also very hard to add something that rigid to a language that already exists. So the path we took with nullable reference types is sort of like a compromise, where first of all, it's optional. You can turn off all the warnings if you mean. It's only warnings. It never changes the semantics of anything you do. It just says, it just changes like what we will warn about. And then it sort of just tries to help you out when it lets you express your intent, right? This is supposed to be null, this is not supposed to be null, and then checks that you are acting according to intent. So it's kind of like a soft touch that I think was the only way to do it in an already mature language and ecosystem, added to existing APIs and so on. While at the same time, catching quite a lot of the null mistakes you might have.
Yeah, exactly. But before moving forward, I just want to ask the question related to async await. So what it took you guys to integrate async await to the language?
Well, it was actually a very difficult process. It was a big, bold language feature. It's not entirely novel. Like the syntax and everything is novel, but it's kind of based on a coroutine kind of mindset, if you will. And C# and other languages already had iterators, which are also like a coroutine mindset. In the sense that you could sort of, in the middle of executing something, you can have a statement that says, hang on a second, let me go, let me wait for something to happen here, and then resume execution, even if you're deeply nested. So it wasn't a new paradigm per se, but it actually took a lot of convincing, and there were several kind of points where we almost gave up on it, because already at that time it was felt that we already have async paradigms. They're already ingrained. We can't go and say, change, remove or replace all these APIs with new shapes and so on. It was, but and finding just the right language feature in and of itself was quite quite a journey. We experimented with lots of different things, and how much should the runtime be involved? How general should it be? Should we have like a coroutine feature, or should we be specific to async? Those many questions. But eventually, we were sort of lucky that with the timing that at that time Microsoft was leaning heavily into cloud programming. We started calling our cloud Azure, and and also the version of Windows that was being built at the time was starting to be much more aware of the risks of blocking threads and that kind of stuff. And so there was the need for the feature grew up around us even as we were building the feature. And eventually it was obvious that, of course, we should have this feature. And now it's completely indispensable in how you interact with the cloud, for instance.
Great. So what was the real reason working on async await? Because as you mentioned, we already had two main features, asynchronous programming model and event-based asynchronous parent, working with asynchronous programming in C#1 APM, in C#2 event-based asynchronous parent, and starting, I guess, C#4.5, you integrated async await to C# language. So what was the main shift, the main reason adding async await? It was in different language, so let's guys integrate async await to our language, or there was a better reason to add it?
Well, it was one of the most common reasons is that there was something that you could do, but it was too hard to do.
Yeah.
Like it's just making life easier. That was the motivation. It was like, and it's not just, when you say easier, it's not just you save a few characters. Like if you try to program to do asynchronous programming without a feature like async await, you have such an uphill climb, right? Because so the typical thing is you have some way of, you sign up callbacks. You say, here's the Lambda or a delegate, and sign it up as a callback for when the thing is ready. But what if something goes wrong? What if what about error handling? So because you can't have the same the same try-catch clauses around the code that sets up the callback and that is in the callback. They don't share that, right? It's all kinds of other control flow that you have. And so what you've seen in many programming paradigms that rely on callbacks explicitly, they end up building a whole copy of the language as a library. They have an if method that you call when you give each of the branches, and you give lambdas for the condition in each of the branches, and while, and so you end up composing.
Readability is getting bad.
You compose your whole program at runtime, and so now we can analyze it, and we can check types and all kinds of stuff. And so it takes all of that program composition back to the compile time. And that really is, it's not just that it's easier to do, it's also that it's a lot less error prone, and so people just have more reliable code.
By far. Async await still is not easy. We are just using async await keywords, but behind the scenes, we have state machine generation. So it is still complex, but the complexity moves it to compiler rather than the user.
Yeah.
So, are you guys still working on making the easy code generation, or still it is as is, like state machine generation, additional IL code generation? How you guys are working on that?
That's a fantastic, well-timed question, because we are, so ever since we added async, back then, by the way, we weren't in a position to add new things to the runtime. So we really didn't feel we had a choice. Like the runtime was it was the old .NET framework times, and it was so intertwined with Windows that we couldn't assume that people had a given runtime on their machine. So we didn't dare add features to the runtime, essentially. So we didn't feel we had much of a choice. But now we do have a choice, and we are actually the sort of doing state machines in the compiler is sort of the wrong layer of abstraction to do this, and we have this lucky situation that all the layers of the of the stack are kind of worked on together. Like we have the libraries, the runtime, the languages, even a lot of the tooling that's out there. And so we actually get to do things in the right place, and we're not so afraid of evolving the runtime now. And we've done it many times since the .NET Core branch of .NET took over. So we are now, in fact, the runtime team is bearing the brunt of this work of re-implementing async in the runtime.
That's great.
Of course, it's harder now because now it has to match the semantics that we already have with those state machines and so on. And we'll see where it goes. Like, I'm making no promises, but it's the work is very far along, and we do intend to make it so that we can embrace runtime implemented async, and also, of course, do the necessary bridging between the two when people are moving across versions and calling across versions. So that is work that's ongoing right now. And you can say, what's the benefit to the user? It's just a different implementation detail, but it's one of those many things where we can really improve the certainly the performance, probably also other things, including I think there'll also be some better like error understanding and stuff like that, because we are not abstracting away or compiling away the shape of the code, but we can improve performance by quite a lot. And
that's fantastic.
That really that starts to matter. In the beginning, async, remember how we didn't up until recently, we didn't have async iterators, for instance, because we said async is for, chunky stuff. It's for it's so expensive that you don't want to use it in a fine-grained manner. You want to have coarse-grained interactions because it's across a wire or something. But increasingly, we've relented and said, you know what? Sometimes you're streaming and you actually do want to have fine-grained async loops and stuff. And we're sort of getting to, because we've gotten really good also with the fine-grained asynchronous interactions. Now the performance overhead of each async call, if you will, starts really to matter. The whole, like, just generating a task, allocating a task at each call all the way up is like starting to show a lot of overhead. And so if the runtime can be involved, they can see, well, no one's actually waiting for anyone all the way into here. So let's not create the tasks in the interim. It can do that kind of stuff. Skip a lot of the work.
That's good. That's good. Yeah, it is fantastic that you guys are working on async await and improving it. So from the developer's perspective, from you guys, from the user's perspective, let's say, still some developers have questions related to async await, especially when they think that there is a special magic thread that handles all this case, but in async await, there is no thread. So how this async await stuff using state machine handles these processes when let's say we have network-based operation, input-output-based operation, the original async mechanism. So how it is handling it without thread, or still there is a special thread to handle it?
There's no special thread for async. All the work that happens has to be done by some existing thread, but there is some magic there that is some of the most complicated stuff about async. So essentially, there's still callbacks under the hood, right? There's when the response comes in, some thread processes the response and it looks to see like who's, what callbacks are there. And the callbacks then have to go and sort of resume the code that was suspended, and that means it has to run. Some thread has to now start running from where we got to, which it should start the running threads are, unfortunately, you would say today, threads are not lightweight in .NET. Like they're good old
Exactly.
heavy threads. They can have thread local state and all kinds of different behavior that varies from thread to thread. So how do you decide which thread to run the code when you're ready to run it? Occasionally, you know, and so there's this notion of like an execution context that is saved
Yeah.
when you suspend, and that is a thing that knows how to go and find the thread to run it. If the await happened on the UI thread, that's sort of like a single threaded environment.
Yeah.
Then the
Configurable.
response will get queued back to that same UI thread, and whenever it's its turn, it gets run, right? But sometimes it might come out of the thread pool, and an existing or new thread pool gets assigned to do the work. So there is thread magic involved. And
Yeah, exactly.
the problem with async is also like the allure is that most of the time when you use it, you don't have to think about that stuff. But sometimes
Sometimes.
if things start to get complicated, now you have to kind of lift the hood, and then all that complexity that we removed from your everyday coding is still there. You still have to kind of
Yeah.
deal with it.
Exactly.
That was the best we could do without kind of like changing the whole threading model, which was considered, and I think still would be like a probably an unrealistic undertaking. But I sometimes a little envious of languages that went with very lightweight threads to begin with. That there are some problems they just don't have. If you can have millions, just spawn millions of concurrent work, you don't need async as much.
Yeah, exactly. So, what is your advice for beginners when they start to learn concurrency? Like we have multi-thread programming, asynchronous programming, parallel programming, all this stuff. And do you think that it is still matter to start from the thread, move to thread pool, move to task, or directly starting learning things from the task parallel library, and async await?
I would mostly still guide people to the task parallel libraries.
Mhm.
And sometimes, because they tend to have slightly higher abstractions.
Yes.
Occasionally, you do want to do just plain old concurrency with locks and stuff. Um, but generally speaking, the coordination mechanisms around concurrency, making sure that you don't have concurrent access to the same data, mutable data, and that kind of stuff. You, you often want slightly higher level abstractions because the low level ones are easy to use wrong. It's easy to handle it. Then you end up having blocks and stuff, right?
But how about from the learning perspective? I was just thinking about the learning perspective. Maybe it is better starting from the thread, not to use it in, let's say, production, but start to like to do some playground and move forward to task parallel library. How about this option?
I certainly, yes. I think depends what kind of learner you are, but and how deeply you want to learn about it.
Mhm.
But oftentimes, if you're like really going in on, okay, I'm going to do concurrent programming, it's usually good to know what's going on, like a layer or two down. That goes for
Mhm.
most things, right? If you understand performance and kind of the gnarly aspects of semantics, sometimes it's good to just understand the underlying basics. And so
Mhm.
going directly to threads and locks and trying to use that is a good. I think that's a good exercise for kind of really understanding what's the raw material of the higher abstractions, and then you can go and use um, use a test and run, that kind of abstraction when you're higher up. Um, another another bit of advice, not so much for learning, I guess, but it
Mhm.
maybe already there it comes in. The thing you quickly realize is that shared mutable state is the root of all evil in concurrent programming.
Exactly.
So
Yeah.
you want to try to make deliberate choices about whether you are, do you want shared? Do you want mutable? Do you want state? um,
Yeah.
like, where do I want to be on that? And one of the things that we've done in C# to help improve many of those concurrent scenarios is immutability, actually, which has nothing to do with it's not a concurrency feature in and of itself. One thing people have been saying for many years is functional languages are much better for concurrency because by default everything is immutable, and you don't have shared mutable state when you don't have mutable state. So our own compiler, Roslyn, is all based on immutable data structures, for instance, because then we can parallelize the heck out of a lot of its algorithms. And it was traditionally the case for C# and other object-oriented languages, and to a degree still is, that mutability is the default. Mutable is the default. But over several releases, we've done many things to make programming with immutable data less of an extra bother, like make it kind of level the playing field so that it's a realistic choice for you to say, I'm actually going to work with immutable data structures. And maybe I use records, I use, read-only state, various things. Maybe I take a less object-oriented view and I have value-based equality instead of reference-based. There are a bunch of practices you can adopt that upfront kind of seem a little more cumbersome. Well, you mean now I can't just change something inside of the data structure? No, you have to go and create a copy where that is changed, and that's a little more work up front. But the payoff, if you want to have a lot of parallelizability, is immense, right? So we tried to make that easier for people as well, and that is kind of, even though it's not really concurrency, it's a set of features that make a certain discipline easier, that enables better concurrency in many scenarios. And so I think if you're learning actually concurrency, you should also learn about immutable data structures. So that would be a good thing to look at.
Yeah, that's great advice. Yeah, that's great. So talking about async await. So regarding to the threads, so let's ask in this way. So the task parallel library uses thread pool behind the scenes. So async await also uses thread pool. So what do you think about using the thread pool directly rather than using these high-level abstractions, for example, in production?
Totally fine. The thread pool is, essentially, when you say task that run, that sort of is what you're doing.
Yeah.
You just the thread pool abstracts this. The thread pool is just like any pool. It's like some threads that have already been allocated. We paid the cost to create these heavyweight threads that we have, for better or worse, and then we reuse them again and again instead of it. It's not really. Using the thread pool is not really that different from just creating new threads every time from a user perspective. It's just that it's cheaper. It's nice. It's nice that the threads get reused, So it's a way to counter the heaviness, the cost of the heaviness of the .NET threads. So you can definitely use it without using all the other bells and whistles. That's a good idea.
Yeah, that's great. That's great. So one of my friends, his name is also Tural, he asked one interesting question. So what lessons from C# would you carry forward if you were designing an entirely new programming language? Let's say tomorrow there is no C#, so you started everything from scratch.
Well, so the things that there are probably things I would try to do similarly and things I would do differently. I think some of the great kind of successful approaches in C# that I would carry forward are be be bold, be willing to do new things often, and be willing to evolve with the state of the art and also sometimes ahead of the state of the art, even if it means adding a new way of doing something you could already do, like async. Because that is the way to stay relevant long term. And you find a way to deal with the legacy aspects of the language. You probably still have to support them forever, but that has been a great successful strategy for us. Another one is be very pragmatic about paradigms, language paradigms. I've already mentioned functional several times.
Definitely.
Functional versus object-oriented. It used to be this kind of clash. It used to be two schools that were at war with each other, which is silly because they actually have so much in common when you look a little deeper. I admire a language like Scala because they really pioneered the idea of truly bringing these two paradigms together. Not just having like two languages smushed together, but deeply reintegrating those. And I like, C# started very object-oriented 20-some years ago.
About this.
It has adopted a lot of functional things, but we've tried very hard to do it in a way where it's kind of deeply integrated. So be pragmatic about, try not to think in paradigms so much and think about, well, what is it why do they love that stuff so much? Is there a way that we can grab it, even though we have a different core, and deeply integrate it and make it ours and make it feel like it belongs in the core? And I would try to take that forward, but that also kind of leads to a number 3 maybe, which is make sure the language has a core. Like make sure that there is a feel to the language. That's really hard to do. Somehow C# managed it, even way back before I joined. I think that having like I don't want to say spiritual core, but like a certain feel to the language that you try to respect is a really good guiding light as it evolves. That's how you can say that's probably not a good fit. That's probably great, or this is what we need to do to it to have it fit together. So it kind of, if you have a strong sense of what the language's identity is, even if it's hard to put into words, that's also something I would aim for. Those 3 things are what comes to mind right now for me.
Oh, that's great. That's great. So, Matt, regarding to the C# programming language, I just forgot to ask about it when we talked about async await. So how you guys are organizing the communication between the original language features? Let's say you're adding async await, and behind the scenes there should IL code generated. Is there any separated team that works on IL language, or the team is one single team? How you guys are organizing it? Okay, we have async await. You guys should generate this sort of IL code behind the scenes.
We have separate teams at the different layers, but we talk a lot, and so we it's not the exception but the rule that we work together across multiple layers. It's not always all the layers. Like most C# features don't need new IL, for instance. We'll actually still talk to the runtime team and say, hey, we plan on using this generation strategy. Is that cool? Is that the best? We will make sure that we close the loop with them. While maybe we are enabling some scenarios that sometimes the language isn't even like the most important part of like a cross stack collaboration. Maybe there's a library push that the library team wants to do that would be enabled and helped by something we do in the language. And we seek that out actively. If we're building a new language feature, even if, we often build very general language features paired with 1 or 2 specific instances of its use, right? Even if it's not the only thing the feature can be used for. An example from a few years ago is that we built interfaces for math. Like the language did a very general feature, which was static virtual members in interfaces, so that not just instance members, but static members can be virtual in interfaces. And one of the things you can do with that is now you can have an interface can specify operators. So that was a big new expressiveness, but it's just one aspect of the feature. You can do many other things, like static factories can now be specified by interfaces and so on. But at the same time, we knew it was an important scenario, and at the same time, we did it at the same time as one of the library teams built a whole set of math interfaces to match, right? So we were proving each other out. Is this language feature expressive enough for you? Does it satisfy the requirements of the library? So we were helping each other out, making sure that what we did had real application and we didn't end up in some echo chamber, but we really try to have real application. You'll often see this. There's one or two things in the library that will use a feature that we do in the language. We do that at the same time, and sometimes when there's a feature in the runtime, usually if it's a new IL instruction or something, that it's fairly rare, but when we do it, we make sure that it's paired with a language feature that makes use of it, so that things hang together up and down the stack.
That's great. So, do you think that makes sense to learn intermediate language directly? Maybe for some optimization perspective, we can use intermediate language directly integrated to C# language, or it is completely okay, just bypass it, and there is no need even to dive into details of intermediate language?
I would say don't bother. It's good to. I recommend being able to teaching yourself to read. Like if you go into what's it called? Well, there are various ways that you can get the generated output of the C# compiler, and that it's a good habit to look at that sometimes. Not necessarily read it line by line. There's a lot of detail, but just to get a sense of what is in fact generated. Sometimes it can be a good way of understanding why something doesn't work the way you thought it would. But the thing is, if you do something in IL, you need to not just understand what it means, but you need to also have a sense of, is this an efficient way? Is this going to be efficient at runtime? Is this a pattern that the runtime will do a good job optimizing away, and that kind of stuff? And that's like very special knowledge that is, not only is it hard to learn and keep track of, but it changes all the time, right? The runtime team sees, oh, we have a lot of code that comes through that looks like this, so let's change, how we execute and optimize for that. And all of a sudden, the whole profile of IL changes a little bit. And that's something that, to some degree, we can do in the compiler for you. And we sometimes change the patterns we generate when we understand that it's no longer the best thing to do. By and large, though, let the runtime optimize. That's the best way.
So it is always possible for the runtime, let's say, to generate most efficient IL code.
Yes, in principle. But it also depends on what you mean by most efficient, most optimal.
Let's say from the execution perspective, the speed perspective.
Right, but there's that trade-off, right? And the runtime will make some trade-off where it will try to make things as fast as possible, but to a point where it's not like allocating 10 times as much memory or something like that, right? So there are trade-offs certainly between time and space. There are also trade-offs because a lot of the optimization happens in a JIT manner, where it's like it takes IL and it says, okay, now let's JIT it. Now let's optimize it further. Like sometimes it even has multiple
Yeah,
phases
exactly.
and so on. And every time you do that work, that's work that happens at runtime as well. So it also needs to do trade-offs about, is it worth doing the work to optimize in terms of what the optimization will gain you? It has to try to predict those things. And so it doesn't, so just by the nature of things, it can't always do the things that turn out to have been the best.
Yeah.
But it does a pretty good job of it. And we have, we have people tinkering with that all the time, with the execution, with the garbage collector, with all those things, so that we don't just sit on our hands here. We try to make it the most snappy, versatile, optimal across the board runtime that we can. And there are also some knobs you can turn if you feel like an expert. There are some knobs you can turn with your runtime and tell it to execute differently and make different trade-offs. But for most people, it's not worth it.
Yeah, definitely. In the last few years, C# really did a good job from the speed perspective, and I'm really happy. So, the last question related to intermediate language. Is it true that there is some features in IL that, for example, it was possible to do in IL in 2010, and C# team activated this feature in a language level in 2023, let's say. It was even possible 10 years ago to implement it in IL language. So is there such type of features in IL?
Yeah, it happens occasionally. So, or another way to put the same thing is C# does not always expose all the expressiveness of IL.
Yeah.
And sometimes there's expressiveness that no one has really made use of. And sometimes we will then say, oh, actually, IL can already do this. Why don't we go and expose that? But sometimes, but to illustrate my point from before, what sometimes happens in that case is that it turns out that the feature didn't actually work exactly as intended because no one was relying on it for decades, right? So I think, don't hold my feet to the fire completely on this, but I believe that a little feature like generic attributes. You used to not be able to have attributes types in C# that were generic, that took type parameters.
Yeah.
For the last couple of releases, you can. The feature has been in IL the whole time. And we talked about it for decades. Should we add that? But then we're like, we're not sure it's reliable. But now we know it's been reliable for a long time. We kind of we did the test and made sure that it's like even several versions back that it's fine. We can do this. And so we exposed that through the language. So that's an example of exactly what you're saying.
Yeah, exactly. And for example, there is one feature in IL that is called modules. Yeah, in .NET there is no such type of functionality like modules, but when you write IL code, there is some dot module. You're specifying your module separately. Yeah, that's great.
Yeah,
that's great.
VB uses modules more directly. So that's an example of an IL abstraction that didn't get exposed up through C#, but did through VB.NET, Visual Basic.NET. So.
Exactly. Yeah, thank you very much for answering. So let's switch to the design decisions and trade-offs. So the first question is, do you think that C# language is really object-oriented programming language?
Yes, I do.
Okay.
Yes, I do. But I'm not going to go into, I used to, as you said, I used to be a professor. I saw all the wars in academia about, no, object-oriented doesn't mean that, it means this, and no, you're being class oriented, and all that kind of stuff. I think that the core in practice, the core of object-oriented programming is that you can have that you have this notion of more general and more specific types or classes or something. I know that there aren't not all object-oriented languages have compliance-time typing, for instance. I'm trying to be general here, and that you can specialize behavior of the objects while still maintaining what you can sort of call subtype polymorphism. You can write code in terms of the general base type, and because all of the objects fit that same mold, even though they have different behaviors, you now have a form of polymorphic code that it works over multiple different shapes of objects through that subtype. That is sort of like the core mechanism that makes something feel object-oriented in my view, as opposed to like functional programming. The way you get polymorphism there is different, right? You get it through type parameters, essentially, where you can't have a given data structure that as easily or they have other mechanisms that are object-oriented. Typically, you want a given array will only have one kind of thing in it, but then you can have different kinds of arrays for type parameters. So anyway, that's C# obviously has that core definition of object-oriented programming. I don't care so much if you call it interfaces or you call it classes or you call it something else. It is the styles you can program in are object-oriented, and the patterns you can kind of lean into in your libraries, that kind of stuff.
Yeah, exactly. So we shouldn't focus, you say that, but we shouldn't focus to the specific paradigm, and the main purpose of C# to bring all the best from the different paradigms, having a hybrid model of paradigms like functional programming, generic paradigm, the object-oriented paradigm, and etc. So does it make the language hard to learn? What do you think about pros and cons having multiple paradigms?
It is definitely a risk. And I think that, to be honest, so as I mentioned before, we really do our best to kind of integrate, to not have too many distinct ways of doing the same thing in C#, but have features work together even if they come from different paradigms. So we do the best we can with that. That said, C# is not a small language, right? It has a lot of features, and so both this kind of pragmatism about the paradigms and also just many years of doing that strategy of eagerly adopting new features every year. It just becomes a big language. I think there are ways to learn C# that it's still that are good, like where you kind of start from the front instead of from the back, and you kind of learn C# at its best usage today. It's what Bill Wagner, who leads our docs, calls everyday C#. There's a way to show that subset of C# that you can do almost everything with. That is sort of like our best bet at how to do things. So lots of new features there because they are better than the old way of doing things. That's why we added them. That said, C# is not optimized for learning. It's optimized it's optimized for professional development, to be honest. It's optimized to be a tool that has a lot of reward for someone who uses it a lot and knows it fairly well. Someone who, if something is awkward, they stub their toe on that 100 times a week instead of twice a week, and so it's really worth it for them to be a way to avoid that, even though it means having the language be a little bigger and having to know a little bit more. Yeah. So that is just, again, that is a matter of strategy, really. It's a matter of how do we think about C# evolution. We let ourselves optimize the tool for the professional tool user, the tool being the language. We try not to overdo it, and we try to, because we can't really take things out, we try to be maybe it doesn't look like it when every year you see six, 7 new features being added, but actually we're trying to be super diligent about not adding something that in 5 years it won't be useful anymore, or that only helps a small number of developers. But even so, the language grows
Definitely.
with our understanding. Hopefully, also grows with the domains that our users have to use it in, so that it stays as relevant in the modern world as it was 20 years ago.
Exactly.
So yeah, that's a trade-off, and yeah, it does mean that it's not optimized for learning. Still think you can have a great time learning C#. I'm not saying it's hard to learn, but
Exactly. I think C# is really easy to learn. So, from the paradigms perspective, do you think that having so much paradigms in C# somehow affect the spiritual core of C# language? How you guys arranging that? Okay, it will harm the core. Let's not to do this, or how you guys are organizing this process?
I think we all feel that part of the core of C# is that it is object-oriented first.
Mhm.
Okay, so no matter how many functional features we add to C#, and it's been a lot over the years,
Definitely.
they have to kind of fit in. We massage them until they fit into this paradigm of object-oriented first. So it's not like, I don't think that we're not trying to be exactly like Scala in that trying to be an exact midpoint between the two.
Mhm.
We have in our spiritual core baggage, it's an object-oriented language. So you will see these functional features being bent and twisted until they click in and feel right with class hierarchies and interfaces and virtual methods and all of that stuff. And mutability too. So that's how we try to address that. And we don't let a feature in until we feel like we have completed that transformation.
Great. So, the question related to the language itself, what's your biggest regret about the feature related to C#? You may think that, okay, we integrated it. Oh my God, it wasn't a good idea to do it.
There are some features in C# that I don't regret because I wasn't around when they were made, but I wish they weren't that way.
Okay. That's going to be interesting. So, which one?
I also have regrets with some of the things that I was very involved in. But I think that as C# was first being built, like we talked before about, if you do a new language, like what would you do? And they were in that situation. I wasn't there, but they were in that situation and trying to build .NET and C# and everything. And there were some choices that were made that I think in hindsight were unfortunate. I'll mention one: events as a language feature. I don't think events should have been a language feature.
What is the reason of something like this?
I think I just think it's too specific. It's events back then, the subject observer pattern, or observer pattern, what you call it, was all erased. Like that was how everything talked to each other, sending events to each other, all that kind of stuff, right? And so I think people believed that it was worthwhile to just make that manifest in the language. But it hasn't stood the test of time. Yes, events are still being used a lot in certain domains, but lots and lots of domains that kind of communication happens completely differently. Even things called events, event queues and whatnot, are not represented well by the event language feature in C#. And so it was overly specific, and it also cost us to come up with this abomination that delegates really are in C#. Like we use delegates a lot. I say as long as you use them just as function types, that is fine. Okay, just think of it as a function type. Then it's kind of okay. Now they're generic, and we have func and action, and it covers most of what you want to do. Okay, but most people don't think about the fact that delegates are also collection types. you can add two delegates together and get another delegate. And when you run it, it will do both of the things.
Definitely.
You can have delegates that are composed of other delegates. And the whole idea for that was because of events. Like you want to sign up events, and so you add to the delegate. So they're a combined function type and collection type. Like, who ordered that? That's crazy, but it seemed right at the time. So I wish we had clean function types, and you would just have done the events at the library level, used collections, lists of them, or whatever. But whatever, that is like, it is what it is.
Definitely, but back then, yeah. Sorry, go ahead. Yeah, yeah, go ahead.
So fewer people use the event feature in the language now because it just didn't stand the test of time. And okay, so it's sitting there, and I wish it wasn't there, but it's not doing much harm. It's just that, water under the bridge.
Exactly. But back then, when we actually used the .NET framework, the classical one, when we developed the Windows Forms application, especially, I think events were not the bad design decision from the language perspective. But nowadays, when we have WPF and we have .NET Core, yeah, it makes less relevant to the language. Yeah, that makes sense. Yeah, exactly.
You can't always know if a thing stands the test of time. Another thing, I think, so I want to mention also dynamic. I was involved very much in the design of the dynamic feature. And I think it is an elegant feature in many ways. I think many of the design decisions we did were clever and elegant, and there was a lot of work done to make it efficient.
Exactly. Yeah. So the background of the language is static. So how you guys make it happen from the dynamic perspective? What did it cost to add dynamic?
That's the thing. The reason we did it, and the reason we thought, well, I'll come back to the cost in a bit, but we thought at the time, there were implementations of Python and Ruby actually on .NET at the time, Iron Python and Ruby. And we actually believed that there was a future where a lot of Python and Ruby would run on .NET. And so being able to have really good interrupt between dynamic and static languages was paramount for that to come to fruition. And we did all the work for that. And then it turned out not really to be in our future. Now there are still scenarios where dynamic is really useful. And I think those scenarios are fine, but it's not necessarily really worth the cost, both in terms of how much infrastructure dynamic takes to work, but also because once you end up in dynamic land, and sometimes it's a little too implicit, all of a sudden you're like, your code is dynamic and you don't really realize it. You didn't say the word dynamic anywhere. You just called something, it returned a dynamic, and everything you do after that is dynamic. It's viral. The overhead execution-wise of all of a sudden going dynamic, doing method lookup at runtime instead of compile time, it's just immense sometimes. And so the performance impact, if you're accidentally dynamic, can be devastating.
Okay.
Yeah. So I'm like, did we really need to do that? On the one hand, a lot of people actually use it and are helped by it. On the other hand, the big core kind of like power of it that we believed we were building it for never came to fruition. So it's not so much that it was a mistake, it's more that it just didn't
work well. Yeah, it didn't work well.
The future didn't turn out the way we imagined.
Okay, so are you guys still working on DLR, improving it from the, I don't know, execution perspective or etc., or is what it is?
It mostly is what it is. If there's if something disastrous crops up, we will certainly maintain it, right? But it's not like we have people working on the DLR every day, the dynamic language run.
Yeah. Okay. That's good. So regarding to the interfaces and abstract classes, the last few years, You guys added some additional features to interfaces, making it look like an abstract classes. And before that, we had a clear vision that this is an interface, so it has just a signature, it doesn't have any implementation. But suddenly it turned out that they are going to be mixed. So when designing our application, how should we design our application from the interfaces and abstract classes perspective? Because often they have overlap in functionality. How do you guide developers on when to use one over the other?
The shortest way for me to say it is do what you always did. The the and it maybe helps to talk a little about the intent behind allowing
Interfaces to
allowing
have implementation.
interfaces are allowed to provide a default implementation of their members.
Definitely.
And the motivation is not that you should now just go and use interfaces instead of abstract classes. The motivation is primarily to support interface evolution. One of the big what has been one of the stumbling blocks with interfaces for people, and one of the reasons some people chose abstract classes over interfaces, even though they lost the multiple inheritance and other goodness of interfaces, was that you can be prior to this, you couldn't add a new member to an interface. So if you realize, say, in version 3 of my library, this interface that everyone's using, it should have this extra member that would be really useful.
Yeah.
Well, you can't do that because now you're breaking every implementer of the interface in the world. Now aren't implementing the interface anymore. They would all get errors if they recompile. And so several languages actually had solutions to that before we did, including Java, which is probably the one we looked at the most. And we're like, you know what? Why don't we alleviate this by saying if you want to evolve an interface, that's fine, but then you should provide a default implementation for the new member in terms of the other members. Make it call the other member to do something, so that you're not breaking all the existing implementers. And at the same time, new implementers can provide their own versions of it. The old ones can go and do that in their own time if they want to, if they don't like the default implementation. But everyone has kind of like a soft landing and a way to evolve. And the consumer of the interface now has this extra member available to them. So that felt like a good kind of smoothing out of that very hard edge. But the intention is not that everything should now be implemented by default.
Got it. So from the, let's say, maintainability perspective of interfaces, from the user's perspective, now it is easy for us to not just, before that, it was really easy to break the contract. Now having the default interface methods allow us to not to break the contract. That's really cool. And even though we should continue follow the path we followed before, like when we're designing interface and abstract classes. Okay, got it. How about I realized that a few years ago, some developers from Microsoft were working on code contracts, the Bertram Myers code contract idea. So suddenly Microsoft stopped maintaining the code contracts. What was the real reason? I don't know if you were involved in this process or not, but it is really interesting for me why they stopped it, because for me this was a really good design decision, especially from the object-oriented perspective. Why throwing exceptions over implementing code contracts?
There are a couple, like we definitely looked at it on several occasions, and I know that there are several research projects that extended C# with code contracts as well as other things. So there were kind of like designs for us to pick up. And we actually, the last one that did it, what was called the Mid-Word project, which was internal and secret at the time, but a lot has been published about it since. we talked a lot to those people, especially because when the project stopped, many of them came and worked with us. And so we talked through the whole code contracts thing. And I think we learned several things. One is, even they were saying that to have a full code contracts feature is actually a very large feature, and it kind of becomes an attractive nuisance because everyone feels like now they should annotate all the details of this method, and the gain you get from that is just not worth either the effort to write the code, the maintenance of all that code, all the extra code that is in those contracts, but also just the expansion of the language's surface area, if you will. It's just too much feature for too little gain. Now, there are ways that you can kind of boil it down to essentials. If you really essentially only do preconditions, that seems to be the most useful part of code contracts, according to these people who played with it. That's what most people essentially want, is to be able to state when you get called, I assume this is true. And then the compiler can check it instead of just throwing exceptions like you would do when you normally like, is this null, is that null at the beginning of a method.
Yeah.
So we were quite interested in that, and we were looking at designs for like, okay, just preconditions, just like a Boolean thing that you can say in the beginning. But then we realized that what people are using it for 90% of the time is nullable. And we could actually do better null checking by far if we had a dedicated nullable reference type feature than if it was in the shape of preconditions only. So we were like, this feature, once we built nullable reference types, it actually kind of motivated nullable reference types. Like, hey, we can do a better thing for 90% of the scenarios, and then the last 10% probably don't matter. We won't do them right now. If they turn out to be important and somebody has enough, like, I want to do all these things, other things with contracts, then we can look at it again. But really, nullable reference types were kind of like they were the last straw for us to abandon thinking about code contracts, because they just do such a better job at solving the main problem that people were using contracts for.
Okay, I got it. But yeah, from the user's perspective, yeah, that was really good design decision. But how about from the language perspective itself? For example, you can implement some feature. I may use it in a wrong way. It doesn't mean that the feature is bad. I'm using it not in a proper manner. So how about this perspective? Because the code contracts you can use for not just precondition, but postcondition, invariance. So yeah.
Yeah, I don't think code contracts are a bad feature. So don't get me wrong. I'm not saying code contracts.
Definitely. Yeah. No. I'm just asking about.
I guess what I'm saying is a feature has to earn its place in the language. The surface area of C# is finite. We talked about how much there is to learn, and so we want the bigger a feature is, the more value it has to come in with for us to pick that feature over one of the hundreds of other features that we could choose to add, right? So it's not, we don't look at a feature in isolation and say, that's a pretty good feature, let's add it. We look at the landscape of all the features we could do next, and we're like, that one doesn't even come into play compared to some of the other things we could do in terms of user value, in terms of the future of the platform, in terms of all kinds of metrics you can think of, efficiency. It's not that it's bad. It's not that it even has negative value. It's just that it doesn't compete for our finite attention and the language's finite surface area. So that's the kind of decision-making process we have to be involved in here. And once we realize the thing about the nullable reference types, the value add of contracts just that we expected. Like you have to make a guess. Of course, you don't know how people are going to use things, but the expected value add just dropped to like a small fraction of what it would otherwise have been. And so we were like, let's not do that. until we have evidence that either there's a much simpler way of doing it, or doing it would give much higher value than we expect. And we haven't reached that point. We haven't really actually seen much move. People pretty much stopped asking for contracts, to be honest. And not completely. I know someone probably asked you to ask the question. So I understand that it's out there, and I understand the need in the scenarios. I'm not saying it's, again, it's not a, I'm not saying it's not a good feature. Just saying that demand is so much smaller now from what we hear that it's just not on the radar, to be honest. Something would have to really change for us to go back and look at it.
Yeah, exactly. The code contract actually was my own question, because in .NET Framework, I really loved using code contracts, and then when we switched it to .NET Core, I realized that people stopped maintaining it. So it was really interesting for me to ask. Yeah, that's great. Thank you very much for clarifying. Yeah.
I will ask you then to, and it doesn't have to be on air right now, but I'm really interested in whether you have scenarios where you still miss it, and what they look like.
No, I don't have any special scenario. Even if we have the nullable reference types, that's completely okay. I was just thinking about the language design perspective, because right now we are implementing features like when we enter to the method, we are checking, we are throwing exception. Even from the functional perspective, we are using result type to not to throw exception. So that's also a good feature to implement. So yeah, it was really interesting for me why people stopped maintaining it. Yeah. That's great. That's great. Thank you very much. Regarding to the garbage collection, I know behind the scenes C# is doing really cool job maintaining all this stuff, tracking all these objects. That's really cool. But do you think that as a software engineers, software developers that uses C# language, we should learn and dive into details of garbage collector? From where we should start to dive into details of garbage collection?
Yeah, the thing about garbage collection, this is a thing that object-oriented and functional languages share, by the way, to some degree, is that we sort of say, you should not worry about memory management. We got you. We'll deal with it for you. You allocate away. And when you're done with your objects, we will realize that, and we'll pick them up and clean them off for you.
Exactly.
And that's good. And in principle, fine. But there's a cost to that picking up and cleaning up after you, right? There's a runtime cost to having a garbage collector. And we have really good garbage collection technology in .NET. And this is a thing that we have people actively working on, and they are smart people, and they do awesome work to make the cost of garbage collection as low as possible. But the thing is that there is a cost, and essentially the cost of garbage collection is really an amortized cost of allocation, right? You allocate, you incur future cost. There's a little cost to the allocation as well, but it's mostly future cost in terms of garbage collection, or indirect cost in terms of the bookkeeping that needs to happen. And so most of the time, for most things, don't worry about it. It's not as if your program runs half as fast or something. Like, it's not a factor of 2, right? It's like, I don't know, 10%. I don't know even what is this days. It's good. It's not a lot. And even if you're like very object-oriented, but if you allocate a lot, and especially if you work with immutable data structures, you will allocate more because you're not actually reusing existing objects. You are creating new ones all the time. It might start to have enough of a performance impact that you're like, should I find ways to allocate less? Again, most people, vast majority of people, don't have to worry about that when they write applications. The people who maybe want to worry about it is if they're writing libraries, and in particular if they're writing performance critical libraries. Now you do need to worry about these things because the impact of your choices is magnified through all your users. Definitely. And that's where it sort of used to be that if you wanted, so we've had structs in the language forever. They're good in the sense that they don't get allocated separately. They don't get their own. They're not objects. Fine.
Yeah, but people are not using structs often. Yeah.
People aren't using them often, and
Oh,
so the first thing to consider is like, okay, if you have a lot of, should I be using more structs or something like that? Other things, but we're also taking steps to make it so that C# has a rich sublanguage, even beyond just structs, for you to write incredibly efficient code that doesn't allocate at all.
okay.
So we have things like span of t and read-only span of t now, for instance, that can represent, contiguous arrays, if you will, that also, if they live on the stack or elsewhere, you can avoid copying or allocating a lot if you use span smartly, but they come with downsides because they're not objects. So you can't, if you have an object, you can't have a span in an object. It has to be, so there's a part of the language that is moving, that is more low level, if you will. There's more discipline that you have to follow. Compiler will help you follow it. It's not as if it's not as a good old unsafe, which people use less and less. It's safe, but there are rules and they're strict to keep it safe while keeping it efficient. And we're finding ways to use that part of the language a lot in sort of the underbelly, like inside of our libraries where people don't even see them, but also exposing, especially spans, in overloads in our API, in our public APIs, in such a way that people, without even having to change their code, they end up calling more efficient overloads because of these things. So we just added a feature to C# that allows you to have params span. It used to be just params arrays. Now you can have params whatever you like. And one of the things is params read-only span, for instance. And that means instead of, when somebody calls a method that's declared with that, instead of it being allocating an array when they pass like 3 arguments, oh, this whole array allocated for these 3 arguments, or 1 argument sometimes, the params span thing, or read-only span thing, can just allocate it on the stack, like where the arguments would have gone anyway, avoid an allocation, make the call faster, do the same thing in the body with those elements. It's free, right? It's just another overload, and it's more efficient now. And that kind of exposing new overloads that make you faster without you having to really think about the rules and regulations around spans, you're just kind of consuming. That seems to be the way forward for these things. So most people still don't have to worry about it much, especially if they're just consuming libraries. You can, if you will, and there's a big rat hole you can go into, but most of the benefit comes from libraries that expose it cleverly, and we certainly do that in our libraries.
Okay. So it makes sense to dive into details if we are writing the performance critical applications and libraries, as you mentioned. Yeah, that's great.
And just measure and see if it's a problem, and then learn what you need to learn in order to make it better.
That's great.
Read Stephen Tobe's blog posts.
Yeah,
that's
definitely.
The best.
I will definitely invite him also to talk about this. Yeah, we talked about nullable reference types, garbage collection, and my question is about records. I really love using them. So what was the main motivation of adding records to the language? Because behind the scenes, there is a syntactical sugar, the magic operations related to record. So why you guys decided, okay, we have classes, structs, maybe adding record like wraps, all this stuff. So what was the real reason of adding records?
So that kind of harks back to something we talked about earlier, where the objects are kind of by nature stateful, okay?
Mm-hmm.
And they represent like a thing in the universe that's being modeled. Sometimes you're not really modeling a thing, or you're not doing it in a stateful way. You're modeling information, or like a snapshot of a thing. So if you think about an administrative system, you have you can choose to have like an object that represents Mads Torgersen, and it'll have, and if Mads goes and something changes about Mads, you'll go and override the state. That's like the standard object oriented. But then the old record of Mads is lost, right? What you might want to do instead, both for but even just for functional purposes, you want to keep information around. You want to work with information, not with objects. It's then you're talking value. Then things you want to represent things as values.
Wow.
Now you're in a world where there can be many different objects that represent Mads Torgersen at different stages or different times, or even alternative versions before they are stored or whatever. Like there's no longer a strong identity. And if you want to work with objects like that, and people are like, why can't you just use structs? They're value types. That would be perfect for that. But structs are way too limited. They can't, a struct can't, let's say a person struct can't refer to another person, right? You can't build like data structures out of them. So they're really limited. What you need is to be able to have objects that you can treat as values. Still allocated on the heap, still has object references, but they're immutable maybe, and they're like, you can treat them as values and treat them as just information. And in order to do that, you want to do some aspects of them differently. For instance, equality. You want to be able to ask if two things are equal, and that does not mean just compare identity. Is Mads? It means actually value-based equality. Are the values inside equal recursively? And so records do that by default. That's the main thing. They do that by default. There are a couple of extra bells and whistles that are cool with records. Like you can have, if you have a primary constructor on a record, then we will automatically we'll automatically give you public properties corresponding to those and a deconstructor to match. So there's some extra syntactic sugar that just comes in that's convenient once you're working with objects as values. And we decided to just package all of that up as one big bundle of syntactic sugar you can get just by putting the little record keyword in front of your class declaration or your struct declaration, as it were. And then you can do value-based programming. So that's the main thing. And it's not just equality, by the way. Like there are some patterns that were really, like I talked about this whole, like how when you work with immutable data structures, you have to kind of create a new one out of some of the pieces of the old one, plus like whatever changed. And records also aid with that. There's the with expression that you can do on a record that gives you a new copy with whatever change that you put in the object initially that you accompany it with. And so it has all this helper functionality for that kind of program. Again, to try to level the playing field between, this is not even between object-oriented and functional programming so much as between mutable or immutable architectures in your program.
Exactly. Yeah. But when you compare records with struct, which one is your preferable?
Depends on if I'm modeling a whole domain, I would use a record because if you want to build a data structure, you need something that is a class. So use a record class. If I'm just kind of like wrapping a few things, then probably a struct is fine, but I may make that struct a record struct then, right? So even for a struct, there's a record version of that. Record is a modifier on struct and class.
Exactly.
And I will often make like a record struct to represent a little agglomeration of data that I want to treat as a value. I want to maybe have automatic constructor, deconstructor properties and all that kind of stuff. I want to, records don't actually have very good equality on their own. I want to get that record-based equality implemented for them. So,
that's a great answer. The last question in this series related to the design decisions. I get really interesting questions related to the complexity in C# and adding features. How you guys are balancing the avoiding complexity in language and adding the feature?
Very carefully. I think
What is a
that,
tool for you to measure it? Like, let's ask this question this way.
yeah, that's a really good question, because we do generally we don't really get to measure until a thing is published, and then it's too late, right? So we have to essentially the biggest tool we have is um, getting a lot of eyes on a feature. So first of all, you notice I've been saying we a lot and not I when it comes
Exactly.
to designing C#. That's because we have a language design team. Now it's a
Okay.
virtual team. It's not like 10 people who design C# every day of their lives. It's like it's me, and then a number of people who have like a day job at Microsoft, in the compiler, the core libraries, or elsewhere. Um, and then they also participate in the C# language design team. So if you have many eyes on it, and a lot of expertise to help reduce the complexity of a given feature to the minimum, and increase the value to the maximum, and all those things. So we have a lot of deliberation that happens in that group.
Mhm.
It
Yeah.
often takes a long time. Like many language features take multiple years from start to
Yeah.
finish, even medium-sized ones. For that reason, like we want to make the best version of the feature we can. Now, so
Great.
that's
Yeah.
part of it. That's how we reduce complexity. But then we also are now open source, which is also a huge tool for us. That a decade ago, that didn't, a little more maybe now, it didn't used to be the case, right? Now we have this vast sounding board of people who participate as a community in the language design before the final decisions are made, and that is a huge source both of ideas, but also of kind of course correction signals for us. So by the time we ship a feature, we generally have as much confidence as you can possibly have without having actually shipped it. Sometimes we even ship preview versions of features. That happens often.
Yeah.
Like a feature will show up in the retail compiler 6 months before the language version is released under the preview language version flag,
Yeah. RC.
so that people can even try them out in their code bases and so on. So we try to get as much feedback as we can, and that's the kind of measurement that we
Oh,
are able to get. Is like,
yeah. So release candidates are really important. Yeah. Yeah. That's great. That's great. So I have the last two questions. One is related to AI tools. So, so the question is, with AI tools like GitHub Copilot gaining traction, do you think language design will shift to cater more AI-driven code generation?
I'm sure some will. I'm actually not hot on that. I know that with the current state of AI, there are some types of mistakes that AIs often make in code generation. Right? There's some
Okay.
things they struggle, like they have, because they are more syntactically than semantically driven. It's syntax with a lot of context, more and more context as they evolve, right? But there
Exactly.
are some mistakes that we would consider basic mistakes that they tend to make at their current state of evolution, and it's tempting to try to make it easier for them by through language design. And it's possible that I will be eating my words a couple of years from now. But I think currently, I think that this is a temporary thing. I think that um, either those kinds of common mistakes will just go away on their own in the language models themselves as they become more capable, or the tooling such as Copilot that we wrap around them is it actually already getting better at then catching that in a deterministic way, like using algorithmic code rather than language models to kind of deal with the last bits and pieces. So I think some people have trumpeted it as kind of like a problem or a thing for a challenge for programming languages. I am not convinced that it is that much of an issue. I think it'll resolve itself in a couple of years. I may be wrong, but that's my current stance. Now, that's another AI-related question that I think we're also all pondering in the programming language community at the moment, which is not so much from the AI tooling perspective, but from
AI
apps using AI, building apps with AI. Like, do we have the right features for integrating with AI, with language models and so on? Do we need, for instance, in C#, does it need to have better ways of processing data streams or other things that are maybe a little less strongly nominally typed than you're used to in C#? I don't have any answers to that, but that's an area that we're watching. That again has to do with making sure that we turn the next corner with our developer customers, so that they are still efficient in C# for their modern needs. So that's definitely something we're watching.
Yeah, that got it. The one additional question related to AI, I don't know to ask or not, but the question is, as you know, the last few years AI started to grow really fast, and most of the developers think that AI will take their job. So do you think that it is still matter to learn programming language, or it is just prompt engineering, just provide the command and the AI will generate everything for you? So maybe in the future there will not be any need for software developers.
I don't believe that. I think AI is certainly going to have probably a transformative impact. It's already having it on the developer landscape, if you will. It's my prediction. And I'm just talking as a person here. I'm not talking. This is not like Microsoft's position or anything like that.
Definitely.
My own sense of it is that AI is a powerful tool. We've had powerful tools before, like even IDEs. Think about IDEs or editors. We used to write code and then compile and see what happened, read the error messages, and then go back and try to fix. And we used to have a very slow feedback loop, even with just like syntactic and semantic correctness, completion. Like if you needed to know what to call, you'd have to go and look up the docs. Like you couldn't just press dot and get completion lists and so on.
Yeah, definitely.
So IDEs are generally used in some like editors to IDEs, and now people expect them to essentially make them a lot more effective and efficient at writing code. Fewer errors because you don't have to try as many things and get compiler errors, and just higher speed at getting the code written. I think AI is the same kind of thing. It might be a step function in how effective and efficient you are as a developer. Certainly when those tools are fully integrated into the developer experience, and they're getting there pretty quickly. So yes, just as much as IDEs caused developers to lose their jobs, AI will cause developers to lose their jobs too. Did IDEs cause developers to lose their jobs? I'm not sure. I think it just raised the level of like what could be done. Eventually, the same number of developers were building more advanced stuff, better stuff, maybe more robust things of higher value. And I'm kind of hopeful that AI is the same way. But we'll see. I think of it as another tool, a transformative tool, an important tool, a step function kind of tool on top of what we have today, but it's not full automation. Like, can you imagine a world where there were not people involved in writing software? Like how many planes would crash? And I mean, it's just like, I don't think that's where we're going to end up. Some tasks will be fully automated, maybe, that aren't today. That has happened before in history. So I'm not completely gloomy about it. I do think that there will be places that there will be companies that will reduce the workforce, and there will be people laid off. I'm not trying to minimize that, but I don't think it's going to be like a complete takeover. I think by and large, it's going to be the same effect as when you add other powerful tools to the stack.
Yeah, I think so. The AI is going to be not replacer but helper, I think. Yeah,
Yeah,
good.
that's certainly how I think about it, and how I know my colleagues are thinking about it. Like, how can we take the developer experience? How can we make the developer the next level of productive and maybe having more joy, doing less grunt work, and having the developer be more like the director and not having to play all the instruments, that kind of
Yeah,
thing.
yeah. At Microsoft MVP, and I have possibility to use GitHub Copilot fully. And sometimes I'm really scared to see the functionalities on GitHub Copilot because it can automatically even generate the full unit tests for you. So that's really cool. And on the other hand, a bit scared functionality of AI tools. So yeah, truth be told, I'm really happy with these features. So the last question is, if you had to choose between C# and F#, I know you love F#, so the question is C# and F#. Let's say you are not lead designer of C#, so you have the choices C#, F#, which one to use?
I love them both, and I think they're both excellent languages of their kind. So I would say it would depend on the task I was facing. It that is, I mean, their F# is functional first with a good helping of object-oriented features. C# is object-oriented first with a good helping of functional features. You'd think that they were pretty similar to programming if you haven't tried both. They're not. Like, it's a very different experience. And actually, I would encourage a lot of people to go and try F# just to have your mind blown at how different it feels. And sometimes there's a different, it's elegant in different ways. And it's hard to kind of say exactly what types of things are easier in F#. It tends to have a higher level of abstraction, and so sometimes your brain hurts while you're writing F#. But on the other hand, when you compile, there's a much higher chance that it actually, when it successfully compiles, there's a much higher chance that it actually runs. It's a different kind of experience. So let's say that I was doing some like signal processing or stuff like that, where I needed a lot of discipline, and a lot, and the data is represented at a very high level. There's not maybe so much UI involved. I might choose to do that in F#, for instance. I'm not trying to pigeonhole it to just those things, but just as an example of things that I would choose F# for.
Yeah, that's a great answer. Yeah. I think I don't have any other questions for you. So thank you very much, Matt. It was my pleasure to host you today, and I hope we'll have another session maybe to dive into details of the other features of C#. By the way, the last question is thank you. As far as I think, C# is growing fast, and the question is where we are going. Adding features, does it mean that from the language perspective, we are adding a lot of features, we are adding tons of features? So do you have, for example, the next 5 years plan of C# that can help us to see where we are going exactly?
I would say, maybe it's a little flippant, I don't know, but I actually believe it. We are going to where the developers are. I think that So we don't really have a 5-year plan.
Mm-hmm.
We certainly have enough features in our kind of big basket of possible futures for the next 5 years and much more, but we're not going to do all of them. So we try to think ahead and trying to guess what are the next things that developers are going to need a few years from now, and also just like what is the state of the art of programming languages where we can do something better than we could before. But we don't have a 5-year plan, and that's quite deliberate. It would be like, holding on to the steering wheel of the car and setting a direction and going straight for 5 kilometers, that's not follow the road. And so we try to put ourselves in a position to be able to react fairly nimbly to the future, even as every single language feature sometimes takes years to produce. That's kind of how we go, so that we're making the choices based on a recent understanding of where things will be helpful a year or two from now.
Yeah, that's a great answer. So the last question, I'm always saying the last question, but I really have some questions on runtime. So the last one is C# defining the rules or following the rules?
The rules?
Or industry. Yeah. Let's say rules, I mean trend. Is C# defining trends or following the trends?
It's some of each, to be honest. I think that's a feedback loop that we're all involved in. As I mentioned, sometimes we're the ones saying, hey, go this way, and people follow. That's great. Sometimes they don't follow, and maybe that's not so great. And sometimes we follow. So I would say yes and to that question.
Yeah,
we certainly don't shy away from like, we don't have to sort of go to upper management and say, don't worry, 3 other programming languages have already done that, so you don't have to worry. Like, we're not afraid to go ahead. So in that sense, we don't limit ourselves to following, but we're also not like stubborn or proud that we won't follow if there's a trend like that. If it makes sense, we'll go there.
Yeah, I think in most cases it is better to follow the trend because they have already tested this feature and they got the positive feedback. So it is even better to follow the rules. And sometimes defining the rules is really harder than following the ones.
One thing you have to really be on the lookout for, though, is differentiating between trends and fads. Like, trend as in a long-term shift in direction, maybe, great. But is it a trend or is it a fad? Is it like all the rage this year and next year it will be, you'll have forgotten about it, or you'll regret that. So that's a difficult distinction to make sometimes. And sometimes we'll wait a little extra until we're sure that something is actually taking and that it is part of the new tool, part of the toolbox for programmers for a good long time into the future.
Exactly. Yeah. Thank you very much, Mads. It was
Thank you. This has been
really, really cool to have you today. I was really pleased to have you, and I'm 100% sure that our audience will have a lot of cool answers to their questions because I collected most of these questions from our audience. So thank you very much for participating in our podcast, and I hope we'll have second session, as I mentioned, to dive into details, maybe async await, maybe the new features of C#, because 2 days ago you introduced really cool features for the C# 14. So I hope, we'll have really cool next session related to deep dive details of C#. So thank you very much for accepting our invitation and for participating, Mads.
Thanks for the opportunity and the invite, and thanks for a very inspiring and fun conversation. I had a great time. Thank you, Tural.
Thank you.